Hello all, in today's session we are going to see Berkeley's algorithm. This is a physical clock synchronization algorithm. In physical clock synchronization, multiple devices are there, multiple nodes are there, and these nodes are having their own physical clocks. So there are chances that every node might be having a clock which might be showing some time, and there might be differences in the times of these nodes. This was the major challenge in physical clock synchronization process. So Berkeley algorithm tries to provide a solution on that. This algorithm is used for clock synchronization purpose. It follows master-slave architecture. So there is one master and multiple slaves can be there. Here the master requests the slaves for their timings, and then accordingly it tries to find out the adjusted timing. The goal of the algorithm is to assign correct timing to the slave. One important assumption is done. Here the master's time is considered as inaccurate time. It is made accurate on the basis of the timings that master receives from the slaves. So there is some mechanism for correcting the time in which master's time as well as slave time is corrected properly. So let's go into the detail. In this algorithm, master requests its slaves periodically and get their times. Further, master calculates the time difference. Now look at this diagram carefully. Here 4 slaves are shown: slave 1, slave 2, slave 3 and slave 4. All these slaves are sending time to master when the master asks the slave for the timing. It happens periodically, and then based on the slave timing it tries to calculate the correct time. So there is a process for that. We will see that process shortly. Now based on the received time differences from different slaves, master calculates the correct time. So it's master's duty to calculate the correct time, but for calculating the correct time master uses the current times of the slaves. Here slave 1 is there, slave 2 is there, 3 is there and 4 is there. Master requests the time from the slaves, and based on the requested times it do some calculation, and then it tries to find out the correct time, and then it gives that correct time back to the slaves, so that the slaves as well as the master into that distributed environment will be having synchronized time, and that will be further used for execution of the different events into the distributed environment. If master fails his work, then what will happen? That is the obvious question. So if master fails in his work, then what happens? New master will be elected, and that new master will work exactly same as that of the earlier master. Now let's go ahead. Let's say that Tm is the master's time. Ts1, Ts2, Ts3 and Ts4 are slave's time. Now let's calculate the correct time with the help of following steps. Now let us go into step number 1. In step number 1, master will collect those physical times from the slaves, and it will try to find out the time difference between its own clock and that of all its slaves. So we can say that that time difference is shown by this formula. Time difference I is equal to TSI. TSI is suppose first slave's time, second slave's time, where I will vary from 1 to n. So TS1 is the time on the slave number 1, TS2 is the time on slave number 2, TSN is the time on slave number n. And the time difference is calculated by subtracting the master's time from the slave's time. Time difference 1, slave number 1's time and master's time. Time difference n will be slave number n's time and master's time will be there. Master also computes the time difference with its own clock. It means that time difference 0, if we say time difference 0 is there, then that will be a time difference between the timings of master's own clock. Here we say Tm is the master's time, so Tm minus Tm will be the time difference 0. Always that value is going to be 0. Now let's go to step number 2. In this step we can say that master computes average of all the differences. Now here we have calculated time differences between the master's time and every slave's time. So that will be our time difference 1, time difference 2, time difference 3, time difference 4, likewise till n, right, if n slaves are there. Now all these time differences we have, we need to find out the average of those all time differences. So I will say T average is equal to time difference 0 plus time difference 1 plus dot 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 plus time difference n. So and divided by n. So as n are the number of non-faulty clocks, we can say, or the number of participant nodes including masters into the distributed environment. So where n is total number of, we can say, non-faulty clocks into that distributed environment. If we see our diagram, in our diagram we are having 4 slaves and 1 master, so all are having their own clocks and the clocks are not faulty. So we can say that in this scenario, in this diagram, we are having total 5 non-faulty clocks. So in the above diagram we have 5 clocks and these 5 clocks are non-faulty, that we will assume. Now let's go to the step number 3. In step number 1 we have calculated the time difference between the master and each and every slave. In step number 2, so we have done average of all the time differences, and now in step number 3, master calculates correct time and sends the adjustment time to the slaves. So what slaves does? Slave adjusts their own time as per the received time. Which is the received time? This is what the received time, as per the received adjustment time. So slave will receive the adjustment time from master, and then they will manage their own time as per the received adjustment time from the master. So timing correction is done as given in the below figure. So we can say that T correct is equal to time of master plus the average time. So here we will say time of master plus average T average time. Now master has corrected its time, it has added the average time. Tm is the master's time and T average is nothing but the average of the time differences, right? So with that we will get the T correct time, so that will be the correction time. Now what will happen? This T correct time will be further sent for time correction to the different slaves by the master, and based on that T correct time, slaves will correct their time. So TS1, that is time of slave 1, will be T correct time which is received from the master minus the current TS1. So when we subtract the value of TS1 from the T correct time which is received from the master, then that will give us the new TS1. That is what we can say that the corrected time of the slave. So TS2 is going to be T correct and the previous TS2. So likewise we can get the times for all the slaves. For n number of slave, for nth slave, we can say that the time will be T correct minus TSN. That is what the old time. Okay, this is what the new time, new synchronized time. Important thing about the adjustment time can be either positive or negative. This can be either positive or negative. So in this way we can calculate the synchronized time at the slave nodes, and all the clocks will be synchronized as per the algorithm of physical clock synchronization. So Berkeley algorithm is an example of physical clock synchronization algorithm.